printed out, it will be equivalent to 20,000 pages in the terms of the Encyclopedia Britannica sets of our youth. Today, I'll be looking at the future of spaceflight, and I've been quite honored that Summer School has used as its overall logo for all the lectures this painting of a futuristic imagined base on Mars, which is all under a big plastic hemispherical greenhouse. And indeed, when the annual temperature range in a typical mid-latitudes of Mars will range between -20 to -60, it is indeed very sensible to be living in a greenhouse. You'll probably need double or triple glazing. To get an estimate of where Astronautics is currently, this is the budget of the current large space powers. All told, governments spend about $76 billion per year on spaceflight. That is over a 1 trillion rand equivalent. The USA spends as much on spaceflight as all other governments combined, $38 billion. Notice that of that $38 billion, only under half goes to NASA, the National Aeronautics and Space Administration. A majority of that money goes to the Pentagon for military space, mostly DARPA. That acronym stands for the Defense Advanced Research Projects Agency. And currently, the space budget makes up just around a little over 1% of the US federal budget. The second largest space budget in the world is China at $10 billion a year. The third largest is Russia at $8.7 billion a year equivalent. The fourth largest, the European Space Agency, $5.7 billion. The fifth largest, India, at $4.3 billion per year. And the sixth largest, Japan, at $3.4 billion. And I think there's a few interesting aspects of this to notice. Of the 6 leading space powers in the world, 3 are in Asia: China, India, and Japan. And that's a sign how the 21st century is so different to the 20th century of the Cold War space race decades over there. The second thing is, as opposed to the second column, which sets out in absolute terms, numbers, the amounts of space budgets, the third column presents that, analyzes the space budget as a percentage of the total national budget of the country. And what is interesting is Russia and its taxpayers are spending more than double a proportion of their budget to anyone else in the world, such as India and China, for instance, there. And what it is that today's Russia, most people feel rather sheepish or ashamed of the Soviet decades, the concentration camps, the censorship, the police state. But the two parts of Soviet legacy that Russian nationalists can feel proud of, the one is, of course, their defense in World War II, but the other one is cosmonautics, the spaceflight heritage of the Soviet decade. So as a matter of national prestige and honor, the Russian government bites the bullet, and notwithstanding austerity in many aspects of public expenditure, gives a bigger commitment proportionally to spaceflight than anyone else in the world. That does mean that there obviously is not any realistic prospect of Russia increasing its space budget in real terms, because it's already making such a sacrifice. We can notice that India at the moment has the fastest growth rate in the world, about 7% economic growth per year. So even if its budget is maintained at 1.64% of the budget, it's going to go up in dollar terms, very interestingly, with every passing decade. Sorry? It is 3.39% expenditure of the whole Russian budget. Oh, sorry, I'm coming on to that. So governments are spending, all told, about that 76 billion, which is 1/5 of all expenditure in space. 4/5 of expenditure in space is from the corporate sector. Now, at a recent International Astronautics conference I attended in Bremen in October, one of the flyers handed out is from an NGO called Moon Village Association. By village it means a moon base, and you can see in that painting that some of the settlement habitats are covered with about 1 meter of moon soil, which is designed to absorb the radiation on an airless body coming down from space, X-rays and gamma rays. Now, of the total global space industry in 2015 was worth $355 billion US. That must be somewhere around 5 trillion rand, just making a very crude analogy. And of that 355 billion, 258 billion is from commercial companies. Now, to look at analyzing this, first of all, in the USA, ever since 1776, it outsources everything possible. Werner von Braun was an exception because of his European heritage. He thought in terms of a state arsenal system, but beyond his spaceflight team, it was contractors. In the space race decades, companies such as General Electric, Martin Marietta, Lockheed were prominent contractors to NASA. Most of the Saturn rocket that went to the moon was built by North American Aviation. In 2019, leading US companies in space are Boeing, and then the highly publicized SpaceX company owned by Elon Musk, who is an internet billionaire and has used his capital to hand to set up SpaceX. With much less publicity, another internet billionaire, Jeff Bezos, has set up a company called Blue Origin, which has also built up, notwithstanding a relative lack of public relations flamboyance, a big manifest of customers who put down deposits to launch their satellites into space. Now, the first big opportunity for the corporate sector in space, beyond of course, building the rockets themselves, came with TV relays that from satellite television, viewers can tune in to something from somewhere else. And the first example of this, for those whose memories go back then, was the Tokyo Olympics of 1964, which were televised in real time by Syncom3 satellite. And that caused a sensation in 1964. Before then, what would happen at the Olympic Games is, of course, newsreels will be filmed. The newsreel canisters will be flown to Hollywood. They will be developed. They will be duplicated and then flown out to the cinemas around the world. Let's say a 3 or 4 week delay before they would reach Cape Town. And this was now in real time, live. So it was a huge impact. And today it's just taken for granted. Sports fans get a 12-month feast of whatever sport they're in because they just follow it from hemisphere to hemisphere, if it's a summer sport or it's a winter sport. We should notice that the profits for making rockets is very marginal. It's a saturated market. It enjoys government subsidies. And there's rather more profit in making satellites, whether TV relay satellites or Earth resource satellites that have got TV cameras, infrared, ultraviolet, and all sorts of other sensors on them. And recently, in fact, Elon Musk announced that SpaceX will diversify into the satellite building sector in order to transfer profits to building of rockets, which is relatively marginal. The largest slice of profits, though, from the space industry are on the ground. They're from the digital processing of imagery and other data received in space. And there's considerable charges made for such services, and of course they sold. Governments typically buy weather data, and of course we take it for granted at 7 or 8 p.m. or 9 p.m. we'll be seeing on our TV sets a photograph of the cloud cover over southern Africa, in which they just added in the political boundaries and done other things there. And another interesting thing I noticed at the 2018 International Astronautics Conference, which has attached to it a large exhibition. And alongside the Chinese National Space Agency stand were stands from several Chinese private companies who are also offering to launch anybody satellites for a fee using their rockets. These private Chinese space companies are not yet on the scale of Malcolm X's Elon Musk SpaceX. They are really launching rockets equivalent to the Falcon 1 that he stopped making. But it's again a fascinating development that the Chinese corporate sector is now going to compete more with the US corporate sector in the satellite launching market over there. Next, I want to look at what I'm going to call the history of our future in space. A quick refresher. You remember that I put up this 1953 painting by Chesley Bonestell from a von Braun authored book, which there depicts astronauts assembling in Earth orbit the spacecraft that will fly to Mars, and you can see in the background there is a large circular space station. And von Braun saw this shows a spacecraft approaching Mars, which has turned its rear to face Mars because it's about to fire its rocket engines for braking and slowing down, and there will be an expedition on the Martian surface. Then the next stage of advocating projects for the future came in 1971 with Peter Glaser advocating the beginning of space industrialization. What he was arguing is that on Earth, solar power, whether photovoltaic or solar concentrated, can only run for 8 hours a day when the sun is sufficiently high above the horizon. But in an appropriate space orbit, you can run your photovoltaic cells for virtually 24 hours every day. So there's triple the generation of electricity per 24-hour period. And also in space, without sunlight being absorbed by the atmosphere, there's about twice as much sunlight per square meter. And he advocated from this space-based solar power, the electricity will be beamed down by microwave to large rectenna in desert regions on the Earth and fed into the national grids in that way. But that, in fact, didn't happen because the costs of moving that infrastructure into orbit are currently far more expensive than the profit that anyone will get from the electricity generated. Then, in 1976, Gerard Neal published a book called The High Frontier, Human Colonies in Space. If anyone here is on South African Twitter or Facebook, I suggest that to get sympathy, you don't use the phrase human colonies in space, but human cities in space, which is what they actually are. And what he is advocating is that to build all these solar power stations in space, you should set up towns of thousands of people comprised of the families of the mechanics and technicians who will be building those solar power in space. And this one painting on the cover of his book depicts a spherical shaped container which is rotating so that centrifugal force provides artificial gravity, and on the inside of it you have a whole township laid out. Another variant of his plans were for what was called the O'Neill cylinder, 8 kilometers in diameter, 32 kilometers long. And again, on the inside of it, you've got strips of what looks like parkland with far bigger gardens than even Bishop's Court or Houghton has. This is another painting from his book. Again, it's showing, it looks like a golf course estate with a staggering amount of meters per person. Now, a quick reality check. If we go back to the slide I showed of the interior of an actually existing space station, you can see that the space per person is more like, say, a submarine than a golf estate over there. So I think it's useful to, from time to time, just hop between the futuristic projects and a quick check on reality that's actually being paid for. There's a second reality check besides the space per person, which we see as a bit more than in a submarine for an individual crew member, but not that more. And that is a reminder that the Earth's atmosphere shields us from a lot of radiation. And as well as the atmosphere, it's the Earth's magnetic field. In the slide, that is the center of the Earth, and the blue lines depict the Earth's magnetic field, which is pushed by the sun's radiation with that purple bow wave and is stretched out in the side of the Earth opposite the sun. Those magnetic fields tend to deflect the sun's energetic particles, though a little bit leaks through the sides and comes down to form the northern and southern lights. But the galactic cosmic rays, which are actual atomic nuclei of helium or lithium, penetrate right through and are shattered in the atmosphere and cause a secondary cascade of particles. Now, on each day you are on the space station, the radiation dose is equivalent to what you get from nature in 2 years in Cape Town. The longest anybody has lived on a space station continuously is Valery Polyakov, who was up for 400 days. But if you're thinking of spending a lifespan in space, you're going to have to accept a higher risk of mutations causing cancers and causing cataracts unless you have radiation shielding, such as 1 meter of concrete or soil around you, and that's very expensive to do. So I think that's another important reality check we should make. Then going back to the futuristic projects, in 1997 and afterwards, John Lewis published a book and then another book over there about mining the moon or asteroids. Now, John Lewis makes it explicit that he is not claiming that mining nickel, cobalt, or platinum from an asteroid is ever going to compete with mines in South Africa for the markets on Earth. All that he is arguing is that moving platinum or nickel from an asteroid or the moon to a space station in high Earth orbit, such as geosynchronous orbit, will involve less fuel than moving it from the Earth's surface up to high Earth orbit. And the market he is seeing in high Earth orbit is building those solar power stations that Peter Glaser was talking about. But of course, the market for mining isn't yet there, as people are not building in high Earth orbit such structures. They are simply launched by rockets from the Earth to high Earth orbit. Now, a yet more futuristic project you can look up on the internet is a club called Asgardia, which advocates that we should send 150 million people to live in towns on the moon and live in orbiting cities around the Earth. It calls its orbiting cities space arks, and in this painting of one you can see there's 3 people walking around on a square that looks about the size of Green Market Square, complete with trees in it, and vast skylights for a panorama of the Earth. And again, notice that the claim to this amount of space per person compared with the existing reality. Now, next, all of you can browse at the SpaceX company website. And one of the paintings on the website depicts what's been named the Super Heavy Falcon rocket, which is going to be designed to carry 100 passengers landing on Mars. And what those 100 passengers are going to do is build SpaceX's spaceport on Mars. There you can see 3 super heavy Falcon rockets, and there's a 4th on the right, landing 400 passengers at a spaceport which has got its terminal in that geodesic dome with trees growing in it. And this is going to continue to happen with each rocket disembarking people until you get a space town of about 100,000 people. There we see 4 of the Falcon rockets, and you notice that the buildings are connected by pressurized walkways, so you don't have to wear a spacesuit but can be in shirt sleeves when you're in that settlement. And if all that seems fairly unreachable, you haven't heard the end of it yet. If you go to meetings of the National Space Society in the USA, the entertainment provided will include this song, among others. See if it works. The singer is Elaine Walker. Oh. Is the audiovisual assistant here? This doesn't seem to be wanting to play. It did when we tested it in advance. I'm sorry about that if the assistant isn't here. Oh. Is the audiovisual assistant here? Well, we just have, sorry, to do without that. It worked when testing. Now, again, trying to assess, oh, they're coming here. Thanks. When I clicked on that, nothing happened. This is the icon that I clicked on to make it play. No, not that one. Go back. Let me do it. Okay. Disappeared entirely. Well, we'll just have to drop it if it doesn't work then and move on. Oh, now it's disappeared from the screen. Yeah. Right, well, thanks for trying to help, but we'll just, it will work now.
Mars, to Mars, we're off to Mars today. It's just one world away. He's calling out our name. To Mars, we're going there to stay. When we're on Mars, we'll be halfway to the stars. To Mars, we're off to Mars today. It's just one world away. He's calling out our name. To Mars, we're going there to stay.
probably the only pop singer who has a Master's of Science in the Mathematics of Chaos Theory. Now, in trying to offer some analysis of the probability of Elon Musk's dreams, my first thought is that if you want to live in an environment which annual temperature range is between -60 and -20, you needn't immigrate to Mars, you can immigrate to the South Pole. Now, it's true that in fact the US South Pole base receives thousands of applications for even the most menial job, such as breakfast cook. And people do apply to return to duty. But you go there for a summer duty of a 6-month tour, or 2 summers and a winter, that's 16 months. No one shows any wish to immigrate to live at the South Pole. Yet the South Pole, there's all the air you need to breathe, you need just to warm it up. And there's all the water that you need, you don't have to carry it with you, you just have to be able to melt it. And it does get about 3 tourists per week throughout the summer 6 months, but no immigrants. And that base fluctuates between 150 in midsummer with 50 scientists and support mechanics and technicians wintering over. The biggest Antarctic base of all, which only the United States could afford, McMurdo Sound, goes up to 1,000 persons in summer, and you can see there a veritable township with streets as well as its airstrips. But again, no one has shown any desire to immigrate and live permanently over there. At the recent conference I was, they were handing out flyers for another conference. You notice this one is being held by the International Academy of Astronautics, and it's on private human access to space, i.e. not government agencies, but private companies over it there. Again, it has Chinese as well as Western persons, and the topics to be discussed are commercial orbital space tourism, reusable vehicles, and bringing down low-cost and efficient space travel technology. So those are just some of the current debates going on.
Keith, before you move off, there's a predominance of men in that dream.
Oh,
A heavy predominance of
very
men.
much so. In fact, at the recent International Astronautics Conference, there was a record proportion of women delegates, over 1/5 of all the delegates, and this is about a 100-fold increase from 10 years ago. So women are moving into the engineering disciplines, very impressive. Now, those Antarctic bases do provide relevant experiences for future astronautical expeditions to consider. For example, there was one person at the South Pole base who got a stroke and had to be medically evacuated. Then another scientist at the South Pole base went down with breast cancer of an aggressive variant. She was injected with chemotherapy, but the tumors continued, and she needed to be evacuated as urgently as possible. Now, flights to the Antarctic are not done in the midwinter 6 months because of such low temperatures. Never mind your antifreeze freezing, your lubrication oils will freeze on an aircraft engine, and at -60, even the fuel will start to freeze in the fuel tanks. So this plane landed, had to keep the engines running, snatch up the evacuee and fly off right away. And notice that this evacuee was herself the base doctor. So there was no doctor when she had left. The relevance of this is that if you're thinking of a moon base, that is only 3 days evacuation back to Earth in any emergency. But if you're thinking of Mars, at the very minimum you're talking of a 4-month trip each way. And if you're trying to be economical on fuel, it could be up to 6 or an 8 months trip over there. Now, in space tourism, I think the most key factor is going to be its cost. And that, as you would expect, there's an inverse ratio between the number of space tourists and the cost of what they're paying for. For example, orbital space tourism has had, in a decade, Mark Shuttleworth and 8 other visitors who enter orbit and visit the space station. The reason is that the cost of such a ticket is 250 million rand for a 7-day holiday in space, sharing the toilet. It has got to do with fuel and no crime. If we go down to many suborbital hops, of which Richard Branson hopes to offer on Virgin Galactic, although it's been delayed for a decade beyond his promises, he's looking at about $200,000 for such a trip. That is roughly 3 million rand to be flown vertically upwards to 100 kilometers and plunge down in about half an hour. So you've got to have 3 million rand for half an hour of fun. He has so far collected 400 people on the waiting list, and they do pay a substantial deposit. He's banked $18 million in deposits. So at the 3 million rand mark, you have 400 customers on your waiting list. If you look at the Antarctic, that gets about 46,000 tourists per year, and those are typically priced between 50,000 to 100,000 rand equivalent if you take it from leaving New York or wherever the tourist is to go to the Antarctic and back again. So those numbers give us an indication of the maximum number of people who will be available for many of these space tourist things planned or visiting the moon or Mars over there. And clearly the key factor is driving behind cost. I must notice here a little forgotten historical fact. Pan American Airlines from 1964 announced it was taking bookings for a trip to the moon, and this cost a $20 deposit. So they had 93,000 people on the waiting list for trips to the moon by the time it closed that list in 1971. Then Pan Am went bankrupt in 1991, and nobody got their deposits back. And this is a warning of corporate failures in the sector. Remember, a few years ago, there was a deodorant adverts on South African TV urging South Africans to apply to be an astronaut who would be launched by X-Core company in one of these suborbital pods. And indeed, a DJ was chosen, and then X-Core went bankrupt. So that was the end of that dream. But the DJ did get sponsorship to get a commercial pilot's flying license, so he got something out of it. Then, a few years ago, we had a non-profit company, called Mars One Foundation, based in the Netherlands, inviting people to be the first people to live on Mars for the rest of their lives. It was a one-way trip, and among the finalists included Adriana Maria of South Africa, who is, I think, a UCT PhD graduate. We've heard nothing much of Mars One Foundation for the last few years because it's unable to raise the funds concerned. Now, the history of trying to bring down the cost of spaceflight, I suppose we should start off with the United States Space Transport System. Everybody calls the space shuttle there. The advocates of the space shuttle made a promise that it would reduce the cost of sending astronauts into orbit to 1/10 the cost of the current cost, and possibly reduce it as much down to 1% of the current cost. However, the US ran out of budget for the research and development of a fully reusable shuttle and made a huge number of compromises in its design, some of which were fatal and at the expense of running up the operational costs. So the reality was that the space shuttle, in fact, cost double any other rocket to launch people to orbit. The reasons were that it was only partially reusable, and as one wit commented, it should rather be called salvageable, and that the solid booster rockets had to be sent back to manufacture to be rebuilt after each launch. It never made more than 4 flights per year, and an airline accountant would tell you that's not the way to run a business. If you look at our jumbo jets, after a 12-hour flight from Europe and North America, they typically only on the runway for 2 hours for cleaning and refueling before a new crew boards to fly them back. So they are 2 hours earning their money and 12 hours earning money non-stop there. Also, salvaging those 2 solid rocket boosters you see on each side required NASA having 2 ships with 2 crews who went out into the Atlantic Ocean to fish out the solid rocket boosters. So you're paying for the wages of 2 crews used on 4 days a year. Now, our South African-born Elon Musk, with his famous Falcon X, he first of all has got the booster rockets to return to Cape Canaveral themselves. This famous slide, again from the company website, shows 2 boosters returning down to the launch pad so they can be used again. And it has so far used one rocket 3 times. Of course, you will need to use it, say, 100 times to make a significant difference to the corporate arithmetic, but it's a huge, huge start. Also, instead of having to pay the crews of 2 ships, SpaceX uses 2 drone barges, that is 2 robot ships that are crewless, which bear the most unusual names of any ships in the world. One is called Just Read the Instructions, and the other one is called Of Course I Still Love You. He's got an amazing flair for publicity and public relations that his rivals don't. So far, SpaceX is doing roughly 1 launch a fortnight, so that is again a rate of use that makes profits more likely. He's used his rockets up to 3 times, and it's enabled him to offer a cut price per launch to attract more customers there. Now, he also plans a capsule, like the Apollo capsule, which is called Dragon, both to take cargo to the space station and to launch astronauts, and the first crewed launch will be within a year or 2. One competitor he's got, or that, sorry, I should say, is making the first stage reusable and also the capsule. But the second stage is once off, it's still expendable. So it's partially reusable, and it's a transition to the spaceflight of the future. Then another rival, the Sierra Nevada, which has made its Dream Chaser, and this has a fascinating history. Back in the 1970s, the Soviet Union planned a crewed space shuttle called Ball 4, and they got as far as launching subscale models of it into orbit, which are recovered in the Indian Ocean and fished out by a Soviet ship. Then the budget ran out, and that would have normally been the end of that. But a Royal Australian Air Force Reconnaissance Aircraft photographed the Soviet ship winching this Ball 4 model out of the Indian Ocean, and that photo caused a sensation among the Western the spaceflight professionals, and NASA gave a budget to a US university to build a ground testing model, not a flight model, which was called HM20. Then NASA ran out of funds, so that would have been the end of that. But then Sierra Nevada company came along and took up the blueprints and slightly modified them to build its Dream Chaser over there. It's so far gone through drop tests and it's got a contract to launch cargo to the space station in the near future. This will be launched on an expendable rocket or maybe on one of Falcon 9s, and so it will land on a runway, which is a great improvement over parachuting down to the ocean or into the desert. So these are partially reusable. However, mathematicians will tell you that the most inefficient mode of reusing a spacecraft is powered ballistic descent. You've got to build it 1/3 larger than otherwise in order to carry all the extra fuel to slow it down when it breaks and to land it softly on the launch pad there. So it is much more efficient to have a winged spaceplane. And this involves something which is counterintuitive when you first mention it, that by adding the weight of wings to a spacecraft, you actually save huge amounts of weight. And the reason is this. If you have a vertically launched ballistic rocket, then of course by definition, the engine thrust must be larger than the weight of tons of the rocket sitting on the launch pad. But if you have a winged aircraft, the engines need not be stronger in thrust than about 1/3 the weight of your spacecraft sitting on the runway. So you save on the weight of the engines, you save a huge amount of fuel and liquid oxygen in launching it up, and in turn you're saving weight on the size of the fuel tanks and your spacecraft altogether. And here I need to start introducing you to an appalling number of acronyms. RLV stands for Reusable Launch Vehicle, HOTL stands for Horizontal Takeoff and Launching, and SSTO stands for Single Stage to Orbit. This is a British proposal from Reaction Engines for their planned Skylon, which is an air-breathing rocket. It takes off, and like any airliner, uses the oxygen in the atmosphere for the first 20 or 30 kilometers of altitude, and only then switches over to pure rocket mode. This means it doesn't have to carry liquid oxygen weight to be consumed during the first 30 kilometers of altitude, so it needs less propellants than other spacecraft. And if that is in fact funded, so far they've got as far as manufacturing scale models of its engine, which the British government is funding on R&D. It would dramatically indeed reduce the cost of launch to orbit to 1/10 of what it is now. There's an Indian spaceplane proposal which is even more advanced, known as Hyperplane in one variant and as Avatar in a 30-ton version. Here we've got yet another acronym to learn. FLOX stands for In-Flight Collection of Liquid Oxygen. And what the Indian engineering team conceptualized is very smart. It's what engineers will call the use of enthalpy. It's propelled by liquid hydrogen, and it takes off with empty oxygen fuel tanks. It flies like any plane up to about 20 or 30 kilometers above the Earth, and then it runs this liquid hydrogen fuel through a heat exchanger, which is used to condense oxygen out of the atmosphere. So it's in effect is using the sky as an aerial refueling tanker. It only fills up its liquid oxygen tank when it's doing about Mach 5 to Mach 7 at 30 kilometers of altitude, and then it goes to orbit. So in other words, it needs less fuel than any other proposed spaceplane because it's taken off with no liquid oxygen weight at all. So it's much more lightweight over there. That too, as is the almost inevitable destiny of reusable launch vehicles, only got funding for the conceptual and blueprint work, but the funds stopped when it came to bringing it to metal. Now, if that was actually built in a large-scale size, it could bring spaceflight down to 1% of current cost. Nevertheless, paying about 3 million rand for a ticket to orbit puts it above most salaried persons. It would be left for business executives, and professionals in private practice would be the limit of your market for space tourism tickets. So how can one reduce costs still lower than that? And there we need to go back to 1889, when the Eiffel Tower was being built. Konstantin Tsiolkovsky in Russia thought, imagine if we could build an Eiffel Tower 36,000 kilometers high. At that altitude, the speed of anything in orbit exactly matches the rotation of the Earth in 24 hours. So if you were to have an Eiffel Tower 36,000 kilometers high, you just push a satellite off the balcony and it would happily float away. And designers started thinking of the terminal of one with a tower going down. One teeny-weeny little engineering problem was that there is no material known to science which could survive the crushing weight of a 36,000 kilometer high tower on it. So that remained just science fiction for about a century, and there are drawings of little maglev cable cars running up and down over there. But then, in the 1970s, chemists discovered a substance which could indeed has the tensile strength to have a 36,000 kilometer long cable hanging from it. And that substance was something called carbon 60 over there. And the secret of that molecule is that all the atoms are arranged like a hollow soccer ball. So it's incredibly lightweight for size compared to any other sort of molecule. Like a soccer ball surface, they're arranged in pentagons and hexagons around it. Then in turn, those molecules can be arranged in a sheet called graphene. The sheet can be rolled up to form a tube called a nanotube. And you can nest nanotube in nanotube in nanotube to build up the strength of this. Now, another reality check is that so far, no one has made a cable 35,000 kilometers long. I think 60 centimeters is the biggest length made to date. And indeed, nearly all of the research projects I can trace on Buckminster fullerene or carbon-16 are interested in chemically doping it to use it as a semiconductor in the electronics industry rather than as a structural material. But there is anyway one concept for what is called a space elevator in the literature. You need to build such a tower very close to the equator so it will switch vertically up and the Earth's rotation will not skew it there. So that would mean that, for example, cities such as Kampala and Nairobi are in prime real estate places to bid to launch the world's first space elevator, to build it down to that city over there. Now, another theme that's perennial topic of discussion is what is today called astrobiology, that is life on other worlds, or even perhaps life floating in interplanetary space, if the panspermia theory is true, that spores and germs can be clinging to dust particles between the planets there. And extraterrestrial or extraterrestrial intelligent life have from the beginning of science fiction almost always been depicted as aggressive imperialist invaders who are out to conquer the world. One very rare exception to this is Neil Blomkamp's District 912, which depicts extraterrestrials arriving as refugees on Earth who cannot return to where they were because of civil war over there. But going back to H.G. Wells, he depicted something which is largely absent from discussion in today's talks about extraterrestrial intelligence. He depicts these invaders after a few weeks on Earth of all dying of our germs, to which they have no resistance to, because they're only used to other sorts of germs. And what may well have inspired H.G. Wells to end his novel on this point is that he was writing in the 1890s when the last living Tasmanian Aborigines died from the common cold, which they were unwittingly infected from missionaries. They had no resistance to it. And of course, from our Cape history, we know how many Khoikhoi and also slaves were killed by imported smallpox, to which they had no resistance. So in other words, if we were ever to meet extraterrestrial life, for both of us, we are deadly to each other and must be treated as biohazard level 4. So you must be wearing the sort of suit that an Ebola doctors wear when they're dealing with those sorts of epidemics, to shake hands very firmly gloved and disinfected on both sides. It might, of course, be possible that essential advances in genetic engineering mean that in future medical technicians will be able to invent a vaccine to some extraterrestrial germ within hours rather than a decade that a vaccine typically takes on the Earth to be safe for tests on human beings. But it's a clear point to be thought of. All the national space agencies already, in fact, have signed protocols about what is called forward contamination and backward contamination. Forward contamination means that you should have each spacecraft sterilized by some chemical poison so that you don't inadvertently carry with it to Mars or somewhere else Earth bacteria, because if they should spread, then future scientists would never know if that bacteria was a contamination or it had independently evolved on Mars because it was present throughout the solar system. Another concern is backward contamination, meaning to make sure you don't bring any viruses or germs from another moon or planet back to Earth, but any return sample must be kept very in sterile containers so that nothing can spread from it there. You also get, like the fear that extraterrestrial aliens would be imperialists, a projection of current Earth anxieties onto outer space in other ways. For example, recently the latest panic is that if you should receive a radio message from an extraterrestrial civilization, you shouldn't record it, because how do you know this doesn't contain malware that you're going to destroy your computers? So it's again inferring notice to others of what is fear on planet Earth. And there is, in fact, while not yet adopted by any government, the International Academy of Astronautics and the International Institute for Space Law have issued a declaration of principles concerning activities following the detection of extraterrestrial intelligence. And the procedure is basically that the scientists who receive this, the astronomers, let's say our SKA, when it's finally built, should first of all confirm that this is indeed not a false alarm, that it's not some natural phenomena which is mimicking an artificial radio